Types of communication: Unicast, broadcast, and multicast. One of the most straightforward topics ever. I bet you already know what these are about, but before you close this video and move on, let me ask you this. Why is the MAC address destination of a multicast frame? If you're like, oh yeah, of course, I know, I'd say hats off to you, and you can close this and go ahead and watch something else. By the way, it's not all Fs, if that's what you were wondering. If you're not sure, I suggest you stick around a little longer so we explore these together. Alright, let's begin. Here is a typical LAN that has a router, a switch, and a bunch of PCs. Our focus here is still around MAC addresses and frames, layer 2 stuff. So we're not going to dive too deep into the layer 3 things, like IP addresses and so on. The source will always be the MAC address of the machine that creates the frame, right? Let's assume that it's this machine right here. So Unicast is one-to-one communication. Therefore, the MAC destination is the one of the machine where it's going. For example, this one. Since MAC addresses are unique, there won't be no mistake, at least in theory. And broadcast is one-to-all, within the LAN obviously. In that case, the 48 bits of the MAC destination will be all set to 1. When converted to hexadecimal, it will give us 12 Fs. So everybody will get it. And everybody will decapsulate the layer 2 header off. It doesn't mean that they will decapsulate it all the way to the application layer. No. It means that it will make it to layer 3 of all the hosts, where layer 3 stuff will happen. Before we move on, I got a question for you. If instead of a switch, we got a hub right here, and this machine sends a frame that has the MAC destination of this machine, where will it go? If you're like, since hubs are layer 1 devices, therefore it will broadcast it everywhere. You're absolutely right. Now my real question is, was that a broadcast or a unicast? Even though everybody got it, it is still a unicast frame, and only this machine will pass it to layer 3. The other ones, they'll be like, nah, that doesn't match my MAC address, and they'll drop it. And if you're thinking that hubs are obsolete and nobody uses them anymore, you're right. But there is attacks that can make a switch behave like a hub, and that's where the worry starts. We'll look at that later as we advance together. Okay, last, but not even close to least, type of communication is multicast. I think you can guess what it is. It's one to many, so it's destined to a group rather than all. I'd like to mention that understanding what we've discussed so far is enough to move on to the other CCNA topics, but I'd like to quickly elaborate a bit regarding this multicast MAC destination, just for the sake of learning new things. Multicast MAC address has 01005E on the left, as defined by the IANA. If you convert this to binary, you'll get 0000001, 8 zeros, and 01011110. Then the next bit is a 0, and you're left with 23 bits to account for, because you need 48 bits. Then we look at the destination IP address. IP addresses are 32 bits long, and there is a specific range that is used for multicasting. Let's use this one as an example. Since we only need 23 bits here, the least significant bits are used to complete it, and the remaining ones are not used. That will give us 000005 in here. If you're not sure about the conversion, you can have a look at the previous video. This is only for IPv4, by the way. IPv6 uses a different strategy, which we'll look at when we get there. Alright, let's wrap this one up. What's this E doing here? Key points to retain is that unicast frames are sent to one machine using the destination's unique MAC address. Broadcast is to all and uses all Fs, and multicast to a group, and we've looked at an example of an IPv4 multicast frame. I hope that this has been informative. I appreciate if you subscribe by making sure that subscribe button is ticked, and stay tuned for more as there is a lot more to come, and thank you for viewing.